Welcome to College Algebra. This is section 1.1 linear equations. This is part 2. We're just going to go over a couple examples solving linear equations. The steps that I listed in part 1, I'm not going to list them again, but I am going to use those same steps. So first example that I have, 6x plus 7 divided by 4x minus 1 equals 3x plus 8 divided by 2x minus 4. So step number 1, and again, if you don't know which steps I'm referring to, I listed 6 steps in the part 1 video to use when solving linear equations. So step 1 was list any restrictions for the variable. What this means is that this denominator, or the denominators that have the variable in it, these cannot equal 0. So x is not allowed to be any number that is going to make this denominator 0, and that would be a restriction. So 4x, so to find those values, 4x minus 1 cannot be equal to 0, and also 2x minus 4 cannot be equal to 0. So we need to solve this. What are the values of x in which would make this denominator 0? So adding 1 to both sides of the equation, then dividing by 4, that's going to give us x cannot be equal to 1/4. And here, moving the x over to the other side and dividing by 2, that is going to be x cannot equal 2. So x is allowed to be any value except for except for 1/4 and 2. So when we solve this, if our value is 1/4 or 2, that can't be our answer. So then we know that it's not solvable. So step number 2. Step 2 was clear all fractions using the least common multiple. So let's switch over to green. Well, our least common multiple in the denominator, here we have 2 separate expressions. In order to eliminate these expressions is just going to be the least common multiple of these 2 expressions is just going to be the product of the 2 expressions. So we're going to multiply both sides by our 2 expressions in the denominator. So we'll have 4x minus 1 times 2x minus 4, and we'll switch back over to purple to write our original equation. Divided by 4x minus 1 equals 3x plus 8 divided by 2x minus 4. And remember, what you do to one side of the equation, you have to do to the other. 4x minus 1 times 2x minus 4. And remember, these things right here, there's all over 1. So now we multiplied by the least common multiple. So now we're going to simplify it. So we have a 4x minus 1 on top here, 4x minus 1 on bottom there. Those will cancel. 2x minus 4 on the bottom here, 2x minus 4 for there. So what we're left with is 2x minus 4 times 6x plus 7 equals 3x plus 8, 4x minus 1. So now we've cleared the fractions. So now we need to get rid of the parentheses. So to get rid of parentheses, we need to distribute. We're going to distribute each of the terms on both sides. So 2x times 6x is going to give us 12x squared. 2x times 7 is plus 14x. Negative 4 times 6 minus 24x. And then negative 4 times positive 7 is going to give us, negative 28. And negative 3x times 4x is 12x squared. 3x times negative 1, negative 3x. 8 times 4x plus 32x. And 8 times negative 1 minus 8. So let's simplify this. The only term, or the only term on both sides that they share, or common terms, are the x's. So we'll have 12x squared minus 10x minus 28 equals 12x squared plus 29x minus 8. So we have a 12x squared here, 12x squared here. They're going to cancel. Next step, collect the terms, meaning move the x's to one side of the equation, move the constants to the other side of the equation. Doesn't matter which one of these you move, as long as you move the variables to one side and the constants to the other side, or all the numbers to the other side. So I'm going to move, let's just move this negative, or move the 29x by subtracting. We're going to subtract both sides by 29x. Negative 39x minus 28 equals minus 8. And now add 28 to both sides. Minus 39x equals positive 20. And then the last step to solve, here we're going to divide both sides by negative 39. And we're left with x equals negative 20 over 39. Again, if you want to write it with solution set, so our answer, negative 20 divided by 39. And if we wanted to check it just to be sure that we have the right answer, what we need to do is take whatever value we got here, this x value, and plug it into every single x value in our original problem. So moving on to the next question, or the next problem. A plus 1 divided by a squared plus 2a minus a plus 4 divided by a squared plus a equals negative 3 divided by a squared plus 3a plus 2. Step 1, list any restrictions in our variable. So again, that is when this denominator is equal to 0. We cannot have an a value that makes this denominator equal to 0. So a squared plus 2a cannot equal 0. A squared plus a cannot equal 0, and a squared plus 3a plus 2 cannot equal 0. Now we just have to solve these couple equations. We have to take out the common term, common factor, a plus 2 cannot equal 0. Taking out an a for both of those again. A plus 1 cannot equal 0. And here we have to factor this. A plus 2, a plus 1 cannot equal 0. And to find the values of a, we have to use what they call the zero product property. And that is setting each of these equal to 0, the product of the two. So a cannot equal 0, and a plus 2 cannot equal 0. Here, same thing, a cannot equal 0, and a plus 1 cannot equal 0. And here, we could do the same thing, but we're going to get the same exact answers as these two, so we really don't have to do this. Here, a cannot equal 0, so we already have these, so now we just have to simplify this one. Moving the 2 over to the other side, moving the 1 over to the other side. That's going to give us 3 restrictions. So a cannot equal 0, a cannot equal -2, and a cannot equal -1. So here are our 3 restrictions before we even start our problem. We have to be sure that a is not equal to any of those 3 values. So we listed our restriction. Step number 2, clear all fractions by using least common multiple. Well, one good thing about finding the restrictions is that we already factored all of these in the denominator. So here, we're going to write a plus 1, and factoring this, a plus 2. So we have a plus 4 divided by a plus 1 equals -3 a plus 1, a plus 2. So the least common multiple between all terms in the denominator, we have an a, we have an a plus 2, and we have an a plus 1. So we have to multiply the entire problem by a times a plus 1 times a plus 2. So rewriting this, a plus 1, a plus 2, whoops, that says a plus 12. And I'll write the original problem back in pink. Equals, and then again we have our right side of our problem multiplied by our least common multiple. All right, so now we have to simplify. We have to multiply this least common multiple by every single thing in our problem. So for our first term, we have an a and an a plus 2 that's going to cancel. So what we're left with is a plus 1 times our a plus 1. So this and that will cancel, and we're left with a plus 1 and a plus 1. Here, a and a plus 1 cancel, and we're left with a plus 2. So a plus 2 and a plus 4. And here we have a plus 1, a plus 2. Those are going to cancel, and we're left with only our a. So we cleared the fractions. Next step, get rid of the parentheses. In order to eliminate the parentheses, we have to distribute. So we're going to distribute each of these a times a, which gives us a squared. A times 1 is plus a. 1 times a, which is a. 1 times 1, which is 1. Minus, I'm just going to put this in parentheses because remember this minus is going to distribute to every term. So a times a, which is a squared. A times 4, which is plus 4a. 2 times a, which is 2a. And 2 times 4, which is plus 8. Equals negative 3a. Remember, this negative, again, is going to distribute to every term. A squared. A plus a is positive 2a plus 1. And we have minus a squared. Negative 4 and negative 2 gives us a negative 6a. And then negative 8 equals negative 3a. So simplify this left side. We have positive a squared, negative a squared. Those are going to cancel. Positive 2a, negative 6 gives us negative 4a. And then positive 1 minus 8 is going to give us minus 7. Equals negative 3a. Step number 5, collect all the variables to one side, everything else to the other side. So we're going to move this 4a since the a's are already by themselves over here. Let's just move this one. But it doesn't really matter which one you do as long as you get the variables to one side. Those are going to cancel. We're left with negative 7 equals 1a. And we can flip these around using the reflexive property. You know, if a equals b, then b equals a. So we can just turn these around. So we'll have a equals negative 7. And written as a solution set, negative 7. All right, so that's going to do it for part 2. There's actually going to be part 3. I know in the first video I said there was only 2 parts of this, but part 3 is going to be linear equations or models of linear equations, aka everybody's favorite word problems. But I hope this helped you. Be sure you drop a like, subscribe if you're not subscribed, and I'll see you later. Bye.